Now, the end of the previous session, we were talking about if you draw a state diagram, a state transition diagram for a PDA, then the labels on the arrows, the transition arrows, they get changed compared to what you did before with a finite automaton. And here's an example, well, in generic case. Here's the sort of thing that you relabel with. Instead of, now, before with just an ordinary so DFA, NFA, you just put the A here on the transition arrow, and that A, if you remember, was the input string symbol, the current input string symbol that you're reading. Well, that's still there, that hasn't changed. Okay, so that's what the A is. And the B, what's that? Well, you've got a stack now, right? And that B is it's the symbol at the top of the stack. Okay. So, in a sense, what here's on the left-hand side of the arrow are two symbols. The first one is the input string symbol that you're reading, and the second one is the stack symbol that you're reading, in a sense. Okay. So, and then arrow and C. What's this C? That's the symbol that you overwrite the B with on your stack, at the top of the stack. Okay. So, so you look at this and you interpret it. Little a, that's the current symbol that if you be yourself, the machine, the automaton, the PDA. So you're reading A on the input string, you're reading B at the top of the stack, okay, and you'll overwrite that B with a C. Okay? That's what it's saying here. Now, if you come down here are some examples of well, the whole thing is a state diagram for a PDA. Now, remember our discussion from now on. Well, a few sessions back, we are assuming that our PDAs are all non-deterministic. Okay. And the reason for that is a bit of revision, is that it's the non-deterministic PDAs, they're more powerful than deterministic PDAs, and it's the non-deterministic PDAs that are equivalent to grammars, to CFGs, to context-free grammars. Okay? Next board we'll start quite a bit of work on theorems about that equivalence. Let's see. Okay, so here 1, 2, 3, 4, 5 examples of transitions, and these are the labels, and you'll see all 5 of them have this pattern. Okay, the current state, the current symbol in the input stream, the current symbol at the top of the stack, and the symbol you will use to overwrite whatever this is. Whatever that was. Okay? So that will become the new symbol at the top of the stack, and that's the current one. All right. So have a look here. What's going on here? So if you're in state Q1, that's the starting state. Here's the starting state arrow indicator. Okay. So if you're in state Q1 and your input is on the input string is nothing, so I guess the input string is just empty. Okay, and what's at the top of the stack is nothing. There's nothing on the stack, in other words. Then put a dollar sign. This symbol here. That's one of your members of your stack alphabet, right? The dollar sign. So put the dollar sign at the top of the stack. Okay. Now you'll see in a minute why you do that. What's another well, there's 5 of them, but let's say you're in state Q3 now, and the symbol, when you read the input string, there's nothing, right? It's just the empty string. Now the empty string includes just not even one symbol, right? And what's at the top of the stack is $. Then remove the $, and then you just put the empty string sign at the top of the stack. Okay, and then, well, you'll move to state Q4. Alright. Now, what's this dollar business about? We can explain that now. It's a trick. Now, the formal definition of a PDA, there's no way to test whether a stack is empty. Okay, so and you need to do that a lot, especially for this particular problem where we're trying to detect strings of the form 1 to the n, 0 to the n. We need to know whether the stack is empty. So how do you do that? Well, you use a trick, and that is at the very beginning, before you start pushing anything onto the stack, you push a $. Okay. So in a sense, you manner of speaking, you're initializing the stack with a $, and then later you'll push 1s and 0s onto the stack. Okay, and then as you keep popping, if you eventually pop, well, if you detect a $, $sign on your stack, then you know the stack is empty. Now it's not really empty because the $,